Let's understand something about mathematical reasoning. And when I say mathematical reasoning, what we are concerned here about is deductive mathematical reasoning. So what you do is, many a times you have many statements. Okay? Let's say you have a statement, girls run faster than boys. Second, I'll consider each one of them and then we'll go through them. Sum of two negative numbers is always negative. Let's take a third sentence, which is today is Sunday, tomorrow is Saturday. Now, if you see each one of these three sentences, what is it that comes in your mind? Or rather, what would you conclude? Let's take first the third sentence. This says, today is Sunday, tomorrow is Saturday. Can this be true ever? No, obviously not. If today is Sunday, tomorrow has to be Monday. Saturday is yesterday, not tomorrow. So we know for sure that this statement is false. Okay? Let's see the second one. You must be thinking, why am I going in the reverse order? Sum of two negative numbers is always negative. You want to try it out? Let's say you have minus 5 plus minus 3. The sum of these two is minus 8. And this is true for any number which is negative. If two numbers are negative, their sum is always going to be negative. So we know that this statement is true. Let's see the third one. The third statement says, girls run faster than boys. Now, is it true? Or is it false? Now, in a logical reasoning, if you see, there could be some girls who might be running faster than the boys. So this may be true for some girls. And on the other hand, there may be some girls who may not be able to run faster than the boys. So it might be false for some more values. Okay? Now, considering this, that this can be true for some values and false for some values, this statement can be both true and false. Now, with this discussion, I come to what do you mean by a mathematical statement? A mathematical statement basically is a sentence which is either true or which is false, but which cannot be both true and false. So it will be either true or it will be false, but it can't be the both of them. So by this reasoning, sentence 3 is only false. It can never be true. So it is a mathematical statement. Similarly, sentence true is also a mathematical statement because it can be true, but sentence 1 can be both true and false, and therefore it is not a mathematical statement. Now this is also the case that mathematical statement can be both true and false. At the same time, there are some other types of mathematical statement which are incapable of determination. Let's say you have a statement wherein you are told sum of two natural numbers is greater than 80. Now you can't say whether this statement is true or false. Why? Let's say you take two natural numbers 1 and 2. So 1 plus 2 is equal to 3, which is not greater than 80. So the statement is false. Now let's take the value of two natural numbers as 56 and 34. So 56 plus 34 gives you 90, which is greater than 80. So this is true. So you are in a situation where you can't find out whether the statement is true or false. Why? Because you don't know the value of these two natural numbers. So these kinds of natural numbers are not mathematical statements. Okay?